My topic for the geometry project is the four-color theorem. The definition of the four-color theorem says that four colors are needed on a map or plane so that none of the countries are adjacent to the country with the same color. Some history on the four-color theorem is that in 1852, Francis Guthrie realized the idea of the four-color theorem. He tried to solve it, but soon realized it was really hard and would take more than just him to solve it. Alfred Kemp came along after him, and he thought he had solved it, but then Percy Hewood found mistakes within his proof. Percy Hewood made major discoveries to help the eventual proof of the four-color theorem, but he also made a six-color theorem, which is a weaker version of the four-color theorem. Francis Guthrie, who, as I said before, was the first one to propose the idea of the four-color theorem in 1852. He was a South African mathematician who studied at the University College in London. He studied under Augustus de Morgan, who was a very influential British mathematician. Alfred Kempf, one of the second main mathematicians who worked on the four-color theorem, was best known for his work on the four-color theorem. He studied at Trinity College under Arthur Cayley. Arthur Cayley was the mathematician who discovered the patch theorem. Percy Hewood, another British mathematician, studied at Queen Elizabeth School, Ipswich, and Exeter College in Oxford. He had a teaching career at Durham University. His relation to the four-color theorem was the six-color theorem. The six-color theorem was basically a restatement of the four-color theorem, saying that instead of using four colors to fill a map or plane, you should use six. Arthur Cayley, who created two theorems to help the four-color theorem, one of them being the patch method, was a British mathematician. He wrote many books, and as a child he enjoyed solving hard math problems, and he always excelled at math. Many mathematicians have commented on the four-color theorem. One of them was philosopher Thomas Tomokozo. He said the four-color theorem is not really a theorem, nor has anybody seen proof that the four-color theorem has a proof. It is unlikely that any mathematician will ever see a proof to the four-color theorem. Another person, who was Apfel, one of the final proof finders to the four-color theorem, said that the computer was much more successful because it was not thinking like a mathematician. While trying to solve the four-color theorem, mathematicians would use a method where they turn maps into planar graphs. They would start by placing a vertice in the center of each country, then connecting each vertices with lines. The end result would be a planar graph. Because of this method, the question arose of whether or not two colors could be used to color in a map or plane. This theory was investigated for a while, but then Apple and Hankel came up with their final theory. The reason Apfel and Hanken made maps into graphs was so that there was no problem with boundary curves or bodies of water in their maps. The proof was finally proved with 50 pages of diagrams with an extra 80 pages with more diagrams and formulas. A computer was used for the final proof. It was called the COQ V7.3.1. It took 12 hours of work. Apfel, the reason the four-color theorem was solved, was an American mathematician. He studied at the University of Illinois, which is where the four-color theorem was solved. He is the reason the four-color theorem is solved today. He wrote many books regarding mathematical topics, and his education was from the University of Michigan, Queens College, and City University of New York. Wolfgang Hanken, who along with Kenneth Apfel solved the four-color theorem, was a mathematician who specialized in topology. He left Germany to be a professor at the University of Illinois, which is where the four-color theorem was solved. The Euler's formula was one of the main things that was used in solving the four-color theorem. The formula goes f plus v minus e equals 2, and then f plus v minus e equals 1. This shows the relationship between trigonometry functions and exponential functions. The Euler's formula was discovered in 1740. It was used by mathematicians who were interested in learning more about imaginary numbers. Arthur Cayley also created the patch method to help him solve the four-color theorem. It showed that when you place a patch over countries that share common borders, new borders will be created. In the first picture, there are 6 borders. In the rest of the pictures, there are 10 borders. The patch created 4 new borders with the countries. Another method that was helpful in solving the 4-color theorem was a method that showed that when you add a region, then you must add a color. As I was doing the 4-color theorem, I wondered what some real-life applications were. I saw that the main theme of the applications was that there was no overlapping between things. Student schedules was one example of a real-life application. Teachers will use the 4-color theorem to make sure that students who have multiple classes when they are taking exams do not have their exam periods overlap. The Euler's formula was very helpful in doing this. Another example is telephone poles. The government will use the 4-color theorem to determine the frequency of telephone poles around the community to make sure all the telephone poles are doing their job purposefully. The Euler formula, which was used to find the relationship between trig functions and exponential functions, and finally the planar graph, which you would use to turn a map into a planar graph to see how the countries corresponded. In the end, it was the computer that did most of the work for solving the 4-color theorem. The COQ 7.1.3 did 12 hours of work that no man could have ever done on their own. Some extra information about the 4-color theorem is that it was also known as Guthrie's problem, since Guthrie was the first person to come up with the idea of the 4-color theorem. It was officially solved with the computer in the late 04s and early 05s. Also, in 1975, an April Fool's joke was played by Martin Gardner. He said that the 5-color theorem replaced the 4-color theorem, so that there was no need for the 4-color theorem. Here are some pictures of the 4-color theorem. The top 2 show examples of how maps and planes are colored in with only 4 colors. And the bottom is a picture of Francis Guthrie, who was the first person to have the idea of the 4-color theorem.